4. Let's copy number 5. Keep an eye on me, what I copy. So 5 on 413. And we said y equals x squared, and this time is 0 to 3. Good. We just had that function, but that's fine. Good. So in order to find the area, we will write what? No more approximations, direct and exact. What do I write? The definite integral from
0 to 3.
Yep, from x squared dx. Which function prime is x squared?
X over 3 to the power 3.
Good. From 0 to 3. Luckily, we don't have to plug in 0 because it will be 0. So then we have 27 divided by 3, which is 9. I want to show you, although we cannot verify in any other way, but I can show you. I don't recommend you use it to learn. I want you to use it to check, which is fine. Go to math and number 9. Here it is. So the integral from 0 to 3 from x squared. Don't forget dx, that's huge. And when I click enter, what should the answer be?
None.
Very good.
Can you show how you did that on the calculator?
Yes, math and number 9. So go to math and go to number 9, and it will pop up. Not all calculators have this feature, though. Good. So let's take a look at something else. Maybe something like this here. Maybe something like this. So let's choose.
We do 13.
Yes, absolutely. 13. Yes. So in 13, same page, we have y equals 2 over x, 1 comma 4. Perfect. Awesome. We want to find the area. Good. So the exact area would be, anyone? Any help? Anyone? We call this the definite integral from
1 to 4.
1 through 4 from the function dx. Remember, the symbol does not exist without this one. This one exists by itself, but this one does not exist without dx or dy. If this is y, then dy. If this is t, then dt. Good. 2 stays outside, like for the limits or function, whatever. Okay. Which function prime is 1 over x? There is only one function that we differentiate to get 1 over x.
Is it a natural log?
Excellent, very much. Very good. Thank you so much. From 1 to 4. Awesome. Leave the constant outside. Make it as easy as possible on yourselves. Please plug in 4. Okay, well, natural log 4 minus. I have to have minus. Careful. This specifically says minus. Okay? Good. So when I plug in 1, what do I get? How much is this? Log in any base of 1. Anyone?
0.
Yes. So the answer is 2, natural log 4. Any questions on this before we move on? Okay.
Yeah, just
Yes.
one question.
Please, anything. Yes.
I kind of got lost with the natural log.
There is a formula that we discussed. The natural log of x prime is 1 over x. So when we integrate 1 over x, so then when we integrate 1 over x dx, we write natural log of the absolute value of x plus a constant c. These are the rules from chapter 3. Not this one. This one. This comes from chapter 3. And of course, this one comes from, no, sorry, chapter 2. And this one is from chapter 4. Is that okay? Is that what?
Yes.
Okay, perfect. Anything else? Other questions? Anyone? Okay, I'm going to share my screen again and we choose. Okay, I think it's my turn to choose. I am going to choose 27. And this is my page 5. And 27 has y equals x squared plus x plus 1. And the interval is 2, 3. Assuming I copied the correct, yes, I did, I think, this time. Good. So we want to find the area under the graph. So the area will be, anyone would like to help?
The definite integral from 2 to 3.
Yes, definite integral from 2 to 3. From x squared plus x plus 1. Awesome. Which function prime I differentiate to get x squared? What?
X cubed over 3,
Plus. Which
and then
function?
plus x squared over 2, and then plus x.
Good. In parentheses, from 2 to 3. And remember what we need to do now. I plug in 3 in all of them. 3 cubed is 27 divided by 3 is 9, plus 9 divided by 2, plus 3. I plugged in 3 in all terms. Now minus, please use parentheses because you may forget to distribute to all terms. When I plug in 2, I get 8 over 3, plus when I plug in 2, I get 4 over 2, and then plus when I plug in 2, I get 2. This is the safe way, so that then I distribute. Okay, first I do this. 9 plus 3, 12, plus 9 halves, minus 8 thirds, and minus 4. Minus, minus, minus. 12 minus 8, minus 4 is 8, plus 9 halves minus 8 thirds. Then I find the least common denominator. For 2 and 3, the least common denominator is 6. And remember, this needs a 6, this needs a 3, and this needs a 2. 48 plus 27 minus 16. I like to do this first because I get 11. And now I add 11 to this to get 59 over 6. Good. So now let's say, oh, I like to check. Fine. That's perfect. You can plug it in. First, I'm going to plug in 59 over 6 because I didn't calculate, so I don't know what that is. So some gibberish. Okay. So we want exact. So go to math, go to 9. Oh, I didn't mean that. Very fidgety. Okay, so x here. Be careful which function you plug in, right? So we have to have x squared, that's the function, and then plus x plus 1. And the limits of integration, although it's not the limit operator, it's the lower number and the upper number. They are called limits of integration. But don't confuse this with the limit. When I click enter, I have to get this. Be very careful because if I make an error in my entry here, I'm not going to get that. Also, it's possible that this is wrong, right? So you can have your open mind. Okay, it's the same. So I checked my definite integral. Can I check indefinite integrals? No, not with a calculator, but I can by differentiating both sides. Okay, good. Oh, I didn't mean to do that. I meant to go back to the book. If I find it. Yes, here it is. Okay, let's move on to the next page and see whatever we get there. And let's look at a word problem. So we have all these problems to look at here, whatever you want to choose, whatever you want to choose. And here they're showing us that the function is given. They're asking us to find the, so yeah, one quick question here for this problem, let's say for 37. So this appears to be symmetric, right? This area appears to be identical with this area. The one above the x-axis is positive. The one below the x-axis is negative. What do you think the answer would be here? And careful, because this is exactly a symmetric interval, right? If the function is symmetric, in this case odd, and the interval is symmetric around the origin, what do you think, wild guess, the answer would be for this? Just a wild guess.
Maybe 0?
Absolutely. Because this is positive and this is negative and they're equal. So keep in mind that the area, for example, here, the area will be negative. Why? Because the whole thing is under the x-axis. No doubt about it. What about here? What do you think? The area will be positive or negative? This is one piece and this is the second piece. So the integral from 0 to 2. Will it be a positive number or a negative number? Your estimation.
Positive?
Yes, because this is much bigger than this. So from a big positive, I subtract a tiny area. So the answer is expected to be positive. Awesome. Okay, so do we want to look at anything from 39 through 58? From 39 through 58.
Could you do 51?
I couldn't hear you. Say, I mean,
Could you do 51?
Yes, 51. Where is it? Yes, perfect. Okay, in 51, we have the integral from 0 to natural log 4 from e to 3x dx. Perfect. Excellent. Thank you. Okay, so now we are asking ourselves what function, when I differentiate it, I get this. And then I will plug in from 0 to natural log 4. And we had this situation last time. We went through it. We had several examples of the situation with when the power of e to the x is not plain x, but different cases. So what do I write?
It will be e3x over 3.
That's it. Awesome. Leave the constant outside. Always try to make your life easier. So now I will plug in e to 3 times natural log 4 minus e to 0. Do not assume that this is 0, right? Because this is not a polynomial. So keep in mind, this happens when the lower limit is 0 and it's a polynomial, that may be 0, but not always. Here it's not 0 because e to 0 is how much?
Is 1.
That's it. So we have a 1/3 in front. This is -1. And now let's discuss this. Yes, we can put this in the graphing calculator to see what it means, but I can tell you what it means. So e to 3 times natural log 4, remember the number in front is basically the power of this number. So we can rewrite it as natural log of 4 to the 3rd power. Because these two have the same base, the answer is 4 to the 3rd. Again, this is one of the properties of the exponentials and log. So the answer is 4 to the 3rd, which is 64. And I can also show you with a calculator. So this is 63 divided by 3, which is 21. So first, I want you to, in case you don't remember, just plug it in as is. E2, don't forget depending on your calculator, you know I'm in love with parentheses, so I have to have parentheses. So, and then 4, and close. When I hit enter, I have to get 64, like we just calculated a second ago, which is 4 to the third. Also, you can verify this with math and number 9, and you can plug in 0. You can plug in natural log 4. You can plug in e to 3x. And don't forget the x. It will not accept it without it. And when I hit enter, the answer has to be 21. If I don't get 21, then I have to go back to the drawing board and whatever I need to do.